Welcome to solverfy.
So now we'll work on question 98 from chapter 17. In this problem, we're asked for each pair of compounds use KSP values to determine which has the greater molar solubility. So our first pair of compounds is cadmium sulfide and copper sulfide. Cadmium sulfide has a KSP value of 8 times 10 to the minus 28. And copper sulfide is 6 times 10 to the minus 37. Now, since we have the same ratio here, 1-to-1 ratio, the KSP value will be equal to x squared for both of them. So the higher KSP value will have the greater molar solubility. So H will be the cadmium sulfide, which has the greater solubility. So we can move on to part B, where the two compounds are lead carbonate and barium chromate. Here the KSP values are 7.4 times 10 to the minus 14 and 2.1 times 10 to the minus 10. So here, same as before, this is a 10. Same as before, the same ratio, 1-to-1 ratio of the ions, so the KSP values will be equal to x squared. So the higher KSP gives the greater solubility. For part C, we're given nickel hydroxide, NiOH2, and nickel carbonate. So the KSP value here is 6.0 times 10 to the minus 16 and 1.3 times 10 to the minus 7. So it might be tempting at first to go ahead and select that higher KSP value, which could be the more soluble one. But because we have a different expression for KSP here, it would be x times 2x squared, which would be 4x cubed. And here it would be simply x squared. We need to go ahead and calculate x just to make sure we know which one. There are some situations in which it could be the lower KSP, which has the higher molar solubility. So if we calculate x by dividing the KSP by 4 and taking the cube root, we get 5.31 times 10 to the negative 6 molar. And for nickel carbonate, we get 3.61 times 10 to the negative 4th molar. So we see that nickel carbonate has the higher molar solubility. So it does, KSP and molar solubility do correlate in this example. In part D, the last part, we're given silver iodide and silver sulfate. So we have for silver iodide, KSP equal to 8.3 times 10 to the minus 17, and for silver sulfate, 1.5 times 10 to the minus 5. And similar to part C, we have different expressions for KSP. Silver iodide would be x squared, silver sulfate is 4x cubed. So just to make sure we calculate x is equal to 9.11 times 10 to the negative 9. And x is equal to 1.55 times 10 to the minus 2 for silver sulfate. So again, the higher KSP gives the higher molar